So basically, my thought is, if you can understand like a spreadsheet, then you can understand like how a database and a SQL relational database works. So you can see what I have here is like Applebee's, and you can imagine that this is a spreadsheet that maybe will keep all of the data related to, let's say we own like an Applebee's franchise, all right, and we might organize our information in terms of, maybe the employees is the first thing we got. So we have like a list of the employees, their name, right? Probably in a real database, you'd have their last name as well. The hometown, like where are they from? There would be a lot more things than this, but this would be one kind of component, and then the second component would be customers. Okay, so just to start putting some names on these things, this entire spreadsheet, meaning like employees, customers, maybe we have something for like the products, right? The menu items, things like that. Maybe we have something for shifts. All of this is going to be in a single database. All right. So in Postgres, in SQLite, regardless of the tool that you use, you would first create a database, which is really just like a container, for the product or for your application, for the entire domain. A single database can have hundreds of tables, hundreds of tables, right? By table, I mean this like employees table, right? The customers table. And like I said, like applications I've worked in that a typical developer would work in can have like hundreds of tables, hundreds of separate containers for each entity. Okay, so this entire database can be quite large. It can really just contain almost all of the data, if not a large portion of the data for like your business or for your web application, regardless, right? And so then we divide this up, right? Each table, you can see we have employees, customers. These are kind of like the nouns. Sometimes you might describe it as that, like the nouns in your domain, right? So if it's like, I own Applebee's, I have, employees and customers, and maybe I have inventory, right? I don't know what, like the furniture, like things like that. I don't know what that's called in a restaurant domain, but those types of anything that we need to keep track of may get a separate table, and you can think of it as almost like the nouns that you're describing. Then, each table you can subdivide into the columns, right, which are the attributes, and then the rows. Okay? So this should start to feel almost like, right, like our list of dictionaries, right, where each row is a separate dictionary, right? And then you can imagine like the key value pair. Okay? So this is, the fundamentals of just how you can start to think of a database. One thing to point out, so I guess a couple of things. So one thing initially to point out is, regardless, we'll use different kinds of databases. That's like the underlying hardware that allows where you store the data. So we'll use, we'll start with SQLite. We'll move on to Postgres. We'll get into Snowflake probably. We'll Redshift, or at least learn how it works. Each of these databases, PySpark even, each of them, you write SQL queries to execute it. In other words, you will see, select all from employees, right? That is a valid statement in any of these databases. So really, like, when people are like, well, I know these different databases, largely you're knowing SQL and then some different ways that these may work underneath, and then I guess some of the consequences for that. But like I said, this is a valid statement in any of these. Okay? So when you hear like Spark or whatever, yeah, you can write SQL. DBT is slightly different, but what you'll be writing in DBT is the same thing. Okay? So that's one thing, is just, this skill set is going to be applicable regardless of the database you use. The second thing is, I guess, like, why do we care about databases in general? There's a couple, because we already have We already have written queries with Python. So why do we even need to learn about this thing? There's a couple reasons. One is, with Python, when we read in a CSV, like if you read in a CSV file, that's pretty slow to actually, if you think about our process, it's something like, let's actually move over to here. If you think about our process with Python, what we do is we do like pd.read_csv, and then we'll read over here, and now we'll then query, to_dict records, and that will be our list of movies, right? And now the next step is kind of write some queries, for movie, in movies, if movie title equals Shawshank or something like that. Okay. So yeah, like we can do this. Every time we read from this though, that's pretty costly. Like in terms of the amount of time it takes. The larger the amount of data we store, the more time it will take to do this. Secondly, so one, loading the data, reading the data we can say from disk. When I say disk, I mean your hard drive, right? When you shut down your computer and you turn it back on again, right? The data is still there because it's stored on your hard drive. But then reading it from disk, this can take a good amount of time, when you get into like 10,000 records, something like that. So just doing that in Python can take a good amount of time. Even, pandas too. You can find, pandas will like really take some time to read in this data once you get into like the tens of thousands of records, meaning like a minute, more than that. So just, right, if you think about a user waiting a minute for you to answer the question, that's not going to work. The other thing is then these queries as well, querying. So we can say one, reading data from disk, and then two, querying data. And in other words, once we read the data, once we load the data into memory, right? Like it's in this variable, and now we search through this variable to find the relevant movie. This also takes longer in Python, right? Querying data more efficient in SQL as well. Okay, so SQL is a good bit faster. The third reason, and this is really like in the last few years has become like kind of a valid reason, is lots of people know how to write SQL, so if the data is kept in SQL in a database, it's more accessible throughout the organization. So people have now actually leaned on SQL even more than they have in the past, in my opinion. And I think like that's what you'll see across organizations. All right, so it's just like more accessible throughout the organization. But these have historically been the reasons. It's like reading the data from disk is faster, querying the data, actually doing this kind of query is more efficient. It takes less time if you do this in SQL. Okay. So moving some, in the long run, we'll see like you'll have a choice between writing stuff in Python or in SQL. I mean, you'll have to know both, but as a developer, you'll have a choice, and the trade-off is, Python, it might, in most cases, takes longer. The benefit of Python is it's more detailed. Like there are things you can do in Python that are much harder to do in SQL. Like the more kind of specific you get with Python. Okay, so now let's move into, so now we know why SQL, right? Like it's faster, both reading data from disk, querying data, more faster as well, more accessible throughout the organization. In terms of actually, writing some SQL or working with it, so what you can do if you have a Mac, if Windows, we can Google this as well. You can do brew install SQLite. Okay, and then once you do that, I already have it on my computer. You can just type SQLite 3, and now I am in SQL land. Okay, so in order to actually work with this, what we'll need to do is one, create like a database and some tables for it. Okay, so let's do that now. I think I can do .exit. Yeah. Let me move into. All right. I'm going to do this for now. Actually, you know what I'll do? I'll write it out in here. So I'll write out my SQL query and then, and then just copy and paste it, which will be a little better. So in order to, the first thing we want to do is actually create this container for employees. And we'll do this. It will be create table employees. I think I can, yeah, that's all right. And then we need parentheses. And now I'll have the name, text, let's say the phone number. Don't do that. Let's just do email, text. And we'll do, and then let's say, that's pretty good for now. So you can see in terms of the syntax, and then I use semicolon at the end. Let me, just so we get some syntax highlighting. Okay, so you can see these are two keywords, right? Meaning like they're from SQL. Create table, this is the command. And then this is the name of the table that we'll be creating. And now here's what's going to be inside the table. So what we're doing is we're defining the columns, right? And we're saying the name of the column and then the kind of data that we're working with. They're different depending on like the type of database you use. These can take on different names, like it could be a string or varchar, really more likely in Postgres. But for SQLite, it's called text, email, text. So this will create a table with these two columns. Let's update this a little bit to now also have an ID, okay? So the ID, typically you have this with every single table. And the reason why is because, let's say you have employees that have the same name, right? Which if you run an Applebee's, right, is pretty typical. Or if you just have like more than 10,000, even 1,000 people, yeah, the chances are one person or multiple people are going to start to have the same name. So you want to identify them by something that just is theirs, and you're not going to have their social, obviously. So in many cases, so we give each individual or each entity its own ID. So ID integer, and we call this thing the primary key. And then you can see, we'll see how this works. If I put this auto increment, then this ID will be self-assigned. As we insert some data into the database, there will, it will start with 1 and then 2 and then etc. Okay, so this is my command to create the table. I'm going to type SQLite 3 and then paste this in here. Create table, the name of the table, the columns. Oh man, see this? I forgot something here, didn't I? Let's exit. If I did this incorrectly, let's just try it. See this? It's just breaking. And it's doing a pretty good job of this is actually very good for SQLite in terms of telling me where the error is. ID, integer, primary key, auto increment, right? And it's really identified it, name, text, right? It thinks it's right here, but really it's right here, but that's still very good. So let's do .quit, and now I'll do a comma here. And now we'll do SQLite again. SQLite 3, I should say. And now let's do that. And you see that? It did not complain. If it doesn't complain, that means he did something okay. There's two ways I can look at this. In SQLite, I think I can do .tables. And now you can see I have this employees table. If I wanted to look at it, like say, okay, show me some data, select all from employees, end with the semicolon, there is nothing coming back because we have not entered any data. So all we've done is we've just created the container, right? The columns, the type of data type, the data type for each column, and the name of the table, but we did not insert in any data at this point. So let me write this out. How do we actually insert in some data? So for this, we do an insert into statement. So it'll be something like insert into the name of the table, employees, and then the columns that we want to insert into. We don't have to insert data into ID, right? Because this is going to auto increment for us. So we'll just do name and email, name, comma, email, and then now I always forget this, values. Okay, so now values, and then we have a tuple of the values that we want, and then end it with a semicolon. So insert into the name of the table, the columns that we'll be specifying, and then these are going to be the actual values that we specify. So this will be, Bob, and we have the email, comma, bob@gmail.com, and then comma, the next one, and now we'll do sam@gmail.com. End the whole statement. So this is the beginning of the statement. We'll end the statement with a semicolon, like always. SQL is very, pretty unforgiving with your syntax, which can be helpful because it forces you to be very specific. All right, insert into employees. What we're inserting in, now comes the values. First tuple, comma, second tuple. See, no complaints. We feel pretty good. Select all from employees, right? And now here's your data. Okay. One thing you can see here is that it says connected to a transient in-memory database, right? These all are things telling you, hey, if you exit this, this is not going to exist here. So what you can do is you can do SQLite 3, let's call it Applebee's .db, and now everything, each of these statements, I'm going to recreate my table, employees, and then I'll do insert into again as well. Paste that down here. Okay, select all from employees. Take a look if I do .exit. Type ls. See this? Applebee's.db. This is just a file on your computer. And if you open this thing, it's not going to make any sense. It's not really human readable. But in that file is your data, right? And is the information about your database. So now, if I do SQLite 3, and now you need to specify the name of the database, Applebee's DB. Okay? So what I'm doing is I'm opening up SQLite, but I'm specifying this database that I'm going to be working with, Applebee's.db, which remember is just this file. Okay? Now if I do something like .tables, you see even though I shut down SQLite, this is still in there, right? The tables, and same with my data. Select all from employees. Okay. So let's just think about what we learned. Okay, we know that we have, okay, we have our database. This is, we use databases because one, it's typically faster just in terms of query time and the time to load your data into memory. Also, right, more people in the organization know about your data. But where is your data stored with any web application, an analytical database, right? Your data is always going to be stored, obviously, in the database, right? And oftentimes we'll see ways to use Python to read the data from the database or to execute SQL from Python and then work with it. We have, the overall database. Typically, there's just one per application or even company. And they may have hundreds of tables where each table is basically a different entity, which I know is kind of vague, but we'll get a feel for this over time. Then we have columns and rows throughout. We saw two SQL statements, right? The first one was create table, name of the table, ID, name, email, text. ID, so it's the column name, type, column name, type, comma between each, and then end each SQL statement with a semicolon. you remember this integer, so I'm specifying the type, and then I'm saying, hey, this primary key means this is how I'm going to identify the record by, okay? I'm not going to use the name. I'm not going to use the email. If I want to, select a specific employee, the way I'll typically do this is with the ID, all right? Just to show you, let's not get into that now, but we'll see that later. And then auto increment obviously means, notice that I never said insert in and specify the ID, but it auto incremented this for me. So this was the first SQL statement. And then the second one is this insert into. Okay, so insert into employees, specify the table name, specify the columns, and then actually have the data. In terms of SQL statements, these are honestly, it's good to know them. They're something I typically have to look up, because oftentimes you're not creating the table, inserting in the data by hand. Most of the time what you're doing is querying the data. So, we have the readings and labs, pay attention to these, but if you kind of forget them and have to look it up at the time being, that's typically fine. This is more being able to read these statements, being able to construct them with some help. That's okay. All right. But you don't have to really, it's okay if you have to look this up every time you have to write a table. That, typically that's fine. I've never seen this asked in an interview. Right. Maybe they'll have you update a table, but you can look and understand the pattern and go from here. But I do want you all just to spend a little bit of time understanding how we create the data, create the tables, and obviously insert in the employees. All right, questions about this material, right? What we went through so far. Okay, so I'll deploy. Let me pause. 1 second. Okay, so if you're on a Mac, right, you can type just the word terminal, I believe, and you should. So what I'm doing is you can click on the Finder and type the word terminal, right, and then just press return, and now I'm in the terminal. Or you can also on a Mac you can press Command Space and be in the terminal. On a Windows, the terminal works a little differently. There is a way to install it for Windows. I forget what it's called. It's I think it's Git Terminal. Yeah, Windows. So you can install, can put this in the Slack, this Git Terminal for Windows, and this is the most similar way to kind of use the same kinds of commands that also work on Linux or Mac machines. All right. So for a Mac, also what I like to download typically is something called iTerm. And you can just type iTerm in Google and then click here and download. It's free. Install it, and it's pretty good. You don't have to. The terminal works fine. It's just some personal preference stuff. Okay, so I'll use iTerm, and now we can, I guess, get started. So in terms of remembering these commands, basically everything you kind of, as we move through these different technologies, you can go think of things as the CRUD operations. What I mean by that is, let's create a new thing. So basically for each one of everything we learn, essentially, you can think of it as CRUD, which stands for create, read, update, right, and then destroy. Okay. Right. So maybe if you think about a list or whatever, it's well, what are the CRUD operations for a list? Well, we know how to create, a new list. In terms of read from a list, right? We know, okay, we can select elements from a list, you know, so your nums, right? You select elements from a list, one or more, update a list, right? You might think of append and then pop, and then destroy the list. I mean, we won't really destroy stuff as much in Python, but maybe if you think, you can think of the whole collection, and then you can also think of an individual element, right? Like, we can add to add a new element, delete an element, right? So it's like you can start to organize, and this is really good for the outline too, right? Thinking of these different commands for each data structure, for everything that we do, right? Create, read, update a table. Create, read, update, a record in a table. Okay? So it's the same thing for, now if we go back to the terminal, there's two kind of different resources, right? We also talked about REST, remember? And that's the idea of resources. So there's two different kinds of resources that we can mainly think of. One is files, and the other one is directories. Okay? So let's do files first. So we can create a new file if we use the touch command. Okay? So I'll do touch, and then let's just call this, it could be, I think for some of you, you got to do this, create employees, right, .sql. The dot at the end doesn't normally mean anything, but it is good it tells you, the programmer, what kind of data or what kind of commands are going to be in that file. It also provides nice syntax highlighting when we eventually will move to a text editor type of thing. So we can do touch create employees.sql, and now if I press return here and type ls, we should see it somewhere. There it is, create employees.sql. So this just added a new file. So this is how we create, right? So for files, we just think about CRUD. Right, so for create, it would be touch. If I want to destroy the file, right, that's remove. So I can do rm and then the name of the file. Okay? Create employees.sql. And now, how am I displaying all these? It's like I'm typing ls, right? ls lists the contents of your current directory. We'll talk about directories in a little bit, but ls just to show the various files and folders. Okay, so this almost is like ls kind of, right? Show files and folders. So we talked about destroy, right? Destroy is rm, file followed by the file name. And this is touch, name of file, whatever it is, rm, the name of the file, .sql. The other thing you can do with files, let's I guess touch it again, touch some file, .sql. We can display, so if I do ls now, we can see that there's some file. We can display the contents of a file by doing cat. So you do cat. This is like concatenate to the screen the contents of the file. So some file.sql. There's nothing in here. Let's maybe change that just barely. So right now I'm going to open up a code editor, VS Code. We'll get into that later on. I'm just doing it for the purpose of adding some stuff. And let's say I have sorry about that. I have create table, employees, and then we have the ID, integer, primary key, auto increment, and then let's do the name is text. Let's put a semicolon here. Okay, so now I just added some text to this file, and so if I do code some file again, so not code some file, cat some file again, this now you can see, right? So this is concatenating to the screen the contents of the file. All right. So what we just went through, right? If we think about files, we went through create, touch, right, with touch, read, I guess, is kind of ls to show like the actual names, but really more like cat than the name of the file, right? Update, where you can do that technically from the terminal. It's probably not, you would more like open up a text editor to do that, and then destroy, right? Destroy what you will use. Remove, so rm stands for remove the name of the file. Okay, so then the next thing to talk about is really directories. So whenever you're in your computer, you're always in some sort of directory. You can go to the Finder in Mac by doing open space dot, and you can see that now I can look at the Finder. All right, and these are the directories I'm in. Now, if I want to make a new directory, I'm just going through the CRUD operations again. So create, read, update, destroy. So what's the first thing? Create, right? So how do I do that? So if I want to make a new directory, right, it's mkdir for make directory, and then the name of the directory. So let's call this like terminal commands. Okay, so this is to create a directory, right, is mkdir. And now if I want to, this is, I can see that by typing ls, but I'm just seeing, you have to think about where we are right now. So here's my terminal commands, and that's because I'm in, this is called the home directory, this tilde thing. This is the home directory, and in the home directory, like Jeffrey Katz, there is this terminal commands directory. If I want to show, right, when I do ls, that shows the contents of the current directory. But if I want to show the contents of, in the current home directory, there are these, various folders that we see here. If I want to look inside of the terminal commands, however, I need to do ls and then the name of the directory, terminal commands. Let me see the question. You can use ls pipe grep file name or ls. Yeah, that's true. Or ls type greps. Yeah, so we'll get into like pipes and grepping in a later lesson. So, okay, so right now, if I do ls, the current directory, I see the contents of that. But if I want to see the contents of terminal commands, I need to specify that, the terminal commands. So ls terminal commands, and notice there's nothing, it did show me that, but there's nothing inside of this directory. Okay, just like we see here, right? There's nothing inside of it. So, so that's to show the contents of a directory. We showed how to create one, how to show the contents of one. If we want to remove an entire directory, it's kind of like removing a file, terminal commands. The only thing is, it's more dangerous to delete an entire folder, right? As opposed to delete like just a single file. So if you just type rm, you see that? It gives you a warning. It says, hey, I'm not going to delete that for you. Terminal commands is a directory. You have to be pretty specific if that you want to do that. So do rm-rf. So this is a flag, and this is the F is for force. In other words, I get that it's a directory. Still, please do it. I'm forcing you to do it. And recursive, the R is for recursive, meaning every subfolder inside of here also delete. Okay? So now I'm deleting terminal commands, and now you can also see it just moved a little here, right? If I do ls, terminal commands is no longer here. Okay? So we saw how to read it. Again, it's kind of like our ls. Destroy is basically our rm flag rf, then the name of the directory. Okay. One thing to, let me see. Okay, one thing to point out is, what do I want to point out? Okay, so we basically just did creating a directory, reading a directory, destroying a directory. One thing to point out is, let's say we do, we want to create a file, okay? And right, this is my create employees.sql. okay? But let's say I want to instead put a space here. That's gonna be an issue, kind of, right? Because in the terminal, every space that you have, it thinks that what you want to do is create two different files. One called create, one called employees.sql. Let's actually just see that. So I'm going to press return, and now type ls. See that? That's my create file. It doesn't make any sense. It has no dot, you know? And then here's the second one, employees.sql. So when you're creating files, just in general, it's also bad practice. Like when you're creating folders, files, always don't use spaces. They're harder to navigate. It shows you didn't create it through using the terminal, but more they are just harder to navigate. So don't do it. Now we have to remove these two. So I just created two by putting a space. I can remove two by doing rm, and then here I do want to actually delete the create file and delete the employees.sql. So our terminal commands, in other words, can take multiple arguments. Okay? We've been passing them one argument so far, but we can pass them multiple arguments. And now if I type ls, notice create is gone, right? And then whatever employees is also gone. Okay, so they're both gone. All right. Questions about, we have more to talk about, but so far what we talked about was creating files, kind of reading both by showing ls to show specific files and directories, files and folders, cat to concatenate the contents of a specific file, rm deletes that file, and then we talked about directories, right? Make directory, mkdir, ls, and then to list the contents of a directory, and then rf. Okay, so Robbie points out, it's also helpful to be consistent with naming conventions between files and folders. That is, using underscores versus using dashes. Right, that works. So, yeah, I actually didn't even think about this, but I think that's pretty good. Notice I'm just naturally doing it, right? I'm using underscores for my directories, right? So, in other words, I'm not like just stringing together my words, but rather, because I don't want to use a space, I put an underscore in between them. Maybe this one I should have used an underscore as well, right? And then with file names, you'll kind of see, like based on the code base, they might say whether or not they prefer to use underscores or like hyphens. I prefer to use underscores. It comes because of, I think in Ruby, that's their preference. So like, yeah, I would say like that's probably fine just to use underscores with them. Cool. Yes, and I would say that too. Keep this stuff pretty well organized, meaning like, yeah, keeping it consistent, at least don't have spaces in between, because obviously like in, you can create a folder through the Finder. Like I never do it, so I don't even, right? That has a space, but don't do it, right? Like it shows you did not create this with the terminal, and also it's harder to navigate, right? If I want to, I'll show you why. So where is it? Do I even see? Oh, there's hello world. So now let's say if I want to ls hello world. In order to do that, you see, you have to do this like / space hello world. Like that's not very comfortable to do. It just gets hard to kind of navigate. Oh, and I have to rm-rf it. So don't do this, right? This is bad news bears. All right. Cool. Now let's move on a little bit more. So basically what I want to talk about now are paths. Okay, so we've been using paths and maybe not realizing it. So every time, when I do like ls, say source, right? This is actually, there's nothing in here. Ls stack exchange. I think this is like some database. Okay, so this is like some set of files. So there are two different ways to kind of do any command, right? Like if I'm saying like look through this directory and tell me what's inside of here, let's do the open dot again, right? If I'm saying like, tell me what's inside of here. Do I have anything in my music? Let's see. Not much. Okay, but I'm saying look inside of here. I'm saying from here, from where I currently am located, okay, from my what's called your present working directory, show me the contents. So basically what I'm saying is pwd from this users/Jeffrey Katz folder, okay, show me what's going on. If I just type ls, it means ls from this directory. So it's like the default argument is your present working directory. However, if I want to, I can, type in the absolute path. So I can say ls/user/Jeffrey Katz from, which is the same thing as the tilde, display all the contents. So this does exactly the same thing. I can do this ls from what happens to be my present working directory, or I can do ls just here. Okay? So you can specify the root. This is called the absolute path. Why is it called the absolute path? Right? Begins with a /. If you use a /, it thinks you are using the absolute paths. Okay? It's called the absolute path because regardless of where you are specifying like how to get to this folder, starting from the very beginning. Okay? So what I mean by the very beginning is, if I want to, I can cd into the /, right? And that is like the start, essentially, of your computer. Like before I even logged in, you can see ls users. This is the root path. So you can see this is the very start of my computer, of basically the folders in my computer. And then I go to /users, what was it before? /users/Jeffrey Katz. Okay? So if I want to change the directory back, it'll be /users/Jeffrey Katz. Okay, so basically I can use the absolute path to specify, list the contents of the absolute path. Let's do that again. So it'll be ls/users/lowercase Jeffrey Katz /practice, right? Regardless of where I am in my computer, I can go to, I'm able to spit out what's inside this folder, practice. Let's go to SciPy. So I'm going to change my directory into SciPy, and now I'm going to do ls, so I'm saying start from the very beginning of your computer, like the very root directory, go to /users/Jeffrey Katz /practice. It's going to still spit out, right? It doesn't matter where I am, it's going to still spit out the same contents and knows exactly what I'm talking about. That is not the case, however, if I use the relative path. So with the relative path, right, I'm saying relative to where I am now, relative to my present working directory, I want you to display the contents of what it was at SciPy. So that would be ls SciPy. That only works because it's from the present working directory. In other words, what the terminal is doing is basically saying, ls users, add this part first and then add in the SciPy. Okay? So that only works because I can see SciPy right here. This takes a little while to get used to. So you have to think about where are you currently, and then this is what I want to display next. If you're using what's called the relative path. Okay, so the relative path means relative to the present working directory. Okay? So this works with basically any of the commands that we've been talking about so far. So, for example, if I'm typing ls and I do ls SciPy, that works right now because my present working directory is users Jeffrey Katz, and I'll do ls SciPy. Okay, that works fine. If, however, let's say I'm going to cd, we'll talk about that in a second, cd out of this directory. So now I'm in the users folder. you can't see SciPy anymore from this directory, right? If I type ls, there is no SciPy anymore. So now if I do ls SciPy, you can see it doesn't work. It says, hey, this guy doesn't exist. Why? Because it's saying /users /SciPy doesn't exist, which is correct. It's really /users /user /Jeffrey Katz /SciPy that exists. So you have to, basically you always have the option of whether or not to use the absolute path, right, which shows you from the very beginning how to get to a directory, or the relative path, right, which is showing you, from your present working directory, how do you get to to the file or folder. Okay, we have to talk about CD next. Which is how you would change which directory I'm in. We certainly have to talk about that. But any questions before I get into that? Okay. So when you open the terminal, right, you're taken to a specific folder. So right, you can see that I'm in this Jeffrey Katz folder. All right, and this is called your home folder. So you can always, the home folder is referred to by the tilde, which is what you can see here. Okay, so I can change into a different folder in other words, it's called change directory. CD is to change your directory, okay, into a different folder. So from here, I'm going to use the relative path, and let's change into my documents folder. Okay, so I just changed my folder into documents by doing CD documents, and now when I type ls, I see what's inside here, wherever it is. I don't see it. It must be there. Downloads. I don't know. Anyway, it's somewhere in there. Let me do this. And maybe I can't see it. I don't know. That's so weird. All right, so I'm going to CD from this directory, ls, CD into documents. And now, right, what's in my present working directory is all the contents of documents, right? Everything inside here. So I type ls, this is the folder I'm in, right? Is inside my documents folder. And, basically everything I type, if I don't specify an argument, what I'm saying is do this relative to my present working directory, which is users, Jeffrey Katz, documents. You can see that naturally I'm kind of going inside and outside of folders. Basically what I'm doing, right now I'm in documents. Documents is located inside of the home directory or the users, Jeffrey Katz. If I want to go to, there's this idea of the parent folder and children folders in the terminal. So what I mean is everything inside the folder is kind of like a child of it, this is contained inside of the documents folder. But if I want to go to, so documents has this as its children. If I want to get to documents parent, what is the parent, do you think? Right? The parent is /user /Jeffrey Katz. Now I can do that by specifying the absolute path and do CD /user /Jeffrey Katz, right? I can always get there from any directory. Okay? And now I'm back there. But let's go back into the documents again. The other way that I can get into documents is by doing CD ... Okay? This references the 2 dots means the parent directory. Okay? So I'm going to do CD ... That would take me outside of the documents folder. Outside of the documents folder, back into the parent directory, which is /user /Jeffrey Katz. So do CD ... That's taking me, do you see that? Now it says the home directory. Okay? Let's type ls again. If I want to go outside of this directory, what's the parent of this? It's /users. So let's do that again. CD ... takes me to /users. What's the parent of this? Let's do this again. So I type pwd. It's just the /. So I'll do CD ... and I'm in the root directory. Okay? So now let's go back. So if I want to go back, I could navigate all the way back Or I could just do cd tilde, change my present working directory to the home directory. Okay, and I'm back here. All right, so we saw how you can change the directory, right? You're changing the directory with the dot dot. Dot dot moves you to the parent folder. Okay, if we want to go to some of the children folders, right? We just do cd and just type the name of the child, basically SciPy, and then I can go from there, type doc. Okay, so I can kind of string these along. And now I'm changing my directory using the relative path, because this is relative to my home directory. I'm going to go to SciPy/doc. Okay? It kind of makes sense. One last thing to talk about right now. If I want to move to the parent directory, I can do the cd dot dot. If I want to do this multiple steps at once, so right now I'm here, typing pwd, users Jeffrey Katz SciPy doc. Let's say I want to move back to SciPy, but not only to SciPy, but to Jeffrey Katz, back to the home. I can do cd dot dot / dot dot. So I'm saying go out one folder, back to SciPy, then go out another folder back to Jeffrey Katz. Right, and now I'm back there. So cd dot dot / dot dot, right? Go back multiple parents. Okay? Okay, one last thing is, what you can see I'm doing lots of times is I'm pressing tab. So this is called like tab completion, right? And it's very, very useful. Like press tab all the time. So for example, let's say I want to use cat to display the contents of a file. Now I could type it out, every character, but chances are I'm going to mistype stuff and it's just gonna be a little slower. So instead you just begin to type, let's just do S. And now I'm going to press tab. I do a single tab. It's showing me basically, here's all the options that you might be referring to. You could want to say you want to display source, you want to display this, you want to display this, right? As I go along, I'll do SOM and type again. Now there's only one option left, some file.sql. So when I did SOM and did just tab, now it completed the rest for me, and now I can just press return, and now it's executing the command, where it's displaying create table.sql. The same thing works with anything. So if I want to remove a specific file, I'll do rm, and then if I just press tab, this could be anything. So it's showing me everything in the folder. Or now I'm going to start to type som, I press tab, and press return, and now it's gone. So this works with really anything. Same thing, cd, I just press tab, cd into the practice, pr, press tab, completes the rest, press return, and I'm there. Okay? So the last thing we saw about was kind of like tab completion. Okay, there are various readings on this. I know that was certainly okay. So let me just walk through, some of the Python. So we're using this, this is a non-standard, there are like these Python standard libraries, right? And this is like import math. So this comes with Python, but SQLite 3 does not, So this is why you may have to do pip install SQLite 3 before you use it. And what this is the Python library for then interacting with your SQLite 3 database, okay? In Google Colab, remember, this is Google's computer that they're basically allowing you to interact with. They have already installed certain libraries for you, so you have this SQLite 3 library already installed, and you can see all the libraries if I do pip list, I think. Let's see. Right, so these are TensorFlow and Triton or whatever that is, Tweepy, maybe that's for Twitter, I'm not sure. So there are a bunch of libraries that they have installed for you, and one of them I'm guessing is SQLite 3. Oh, it's not even listed here, but it should. I guess it just is there. It's weird that it's not showing up. Maybe it's under. Maybe I might have to do pip 3 list, and then it would show up. These are the Python 3 libraries. I'm surprised. So maybe it's installed along with something else, but I don't know why I can't see it. Anyway, so this is what we have is this SQLite 3, right? This is a Python library used to interact with SQLite 3 database. There is a terminal here, but you have to pay money for it in order to actually get access to it. So instead, our way of interacting with it is like the exclamation point before the terminal commands. So once we import the SQLite 3 library, then we can connect to a database called, right, like mean, whatever we want to call it. This is just a name. And now this is my connection to the database, right? So from there, we can do like, connection.cursor, right? And that gives us a cursor. And that's how we actually execute certain queries, right? Write commands against this database, right? So it's like this cursor is connected from this connection object, and then the connection object, right, we're saying here is connected to this database, which is just a file. Then what we'll do is we can read in some data. I'm lying. I need to import pandas as PD. And then we can read in some data. You can see that I just have like a CSV file over here, employees.csv, somewhere on GitHub. And then if you take a look at the data frame, right, we have some data here. But what you can do is you can do df to SQL, and then we'll pass through our connection, right? Like this to SQL method takes an argument as the table name, and then the connection object, this is like a connection to the database. We're saying we don't need to add like a new index here. So basically what we're saying is take this data, this whole data frame, and create this table. And now if we do something like connection, let's take our cursor. Did I not do it? Let's run this. Connection.cursor parentheses creates a new cursor object. And remember, this connection is related to this guy, and we just inserted data into that database, the meangreen.db database, and we created a new table called employees. So now if I look at my cursor object, I can do something like cursor.execute, select all from employees, and then do cursor.fetch all. Okay, and this is selecting the data. So it's selecting from the employees table, and the way that and from the mean green database, and the reason why it's connected is because this cursor object comes from this connection object, which is connected to the mean green database. All right. A nicer way to actually do this is you can do pandas has this pd.read SQL, and then you can just pass through your SQL here, select all from employees, and then you can pass through, I think, the connection object there. Does that work? Yeah. So this is actually nicer, I think, because you can see the column names here. Okay. All right, so what we did, right, we read in some data, then we used the df.toSQL and passed through the connection object, right? And the connection object, we created a connection to a database. If this database file doesn't exist, it will create it for us. So you can see this actually over here, this meangreen.db, and that's what it's connecting to. If it created it the first time, and then afterwards it's just connecting to it. And then I can do pd.read SQL from this database, right? Select all from employees in here. Questions about that before we go into select statements? Let's see. Oh, that's cool. You can use SQL Alchemy to interact with SQL. So maybe it was coming from SQL Alchemy. I'm not sure. All right. So we can read SQL, select all from employees. Let's get into these statements. So basically, select is saying that we want to query. And then here we're saying, and by the way, people argue about whether or not you should do the SQL keywords in all caps or not. I think now most people actually do it lowercase lots of times. So select all from the table name. So what you want to imagine is that we're basically, remember, our table has data stored on disk, and the from statement is saying I want to load this data, this employee's table, into memory. Okay? The star here we're specifying the columns that we want to be displayed. Okay? So what comes after the star is much more about like what's being displayed back to you. So here the star is indicating all of the columns. However, we could do something like, all right, let's just see the ID and the name. Okay? So notice I'm putting, whoa, was I muted? No? Oh, okay. I don't know why it said something like I was muted. All right. So now we can specify each of the columns that we want to display back if we want a subset of the columns, right? Notice I'm putting a comma between each one here. So, right, so now I'm just getting the ID and the name. Right? And I can always obviously go back to select all from employees. Okay. Other things to do, so select star from the employees. So we just saw how we can limit the number of columns, right, by specifying them. You can also limit like the number of rows. So now we'll say from employees, and you can imagine where. Then it's like where, let's say the name equals, if I do this single quotes here, it's going to think I'm ending. I don't think it will work because it'll think I'm ending the string here. So I just have to be careful. I can do double quotes. So name equals, let's say Fred. You see that? So now what's happening is we're selecting all the columns, right, from the employees table where the name equals Fred. So it's searching through all the records, looking to see where there is a match. Notice with the equal sign, it's just as in SQL, it's just a single equals. Right? But we know that with Python, right, it's, Fred double equals. Okay? So the syntax is different based on if this is Python or SQL. So SQL is just a single equal sign. And just like Python, obviously, the capitalization matters. So here there's no matches. You can string these together. So you can say where the name equals Fred. I think you'd have to do where name equals Bob. I don't know if you can. Yeah, so we can do that. I don't think we can do this. If we just say name equals Fred or Bob, let's see, does that work? Oh, that works. Okay. Oh, no, it doesn't work. Name equals Fred or Bob. It actually just returns one. Let's see this. Now we get both of them. Okay. I wish it would have errored before. So name equals Fred. Yeah, you can also use in. Well, let's get to that in a second. So we have where name equals Fred or the name equals Bob. So that what Narapati was talking about is if you want, just like with Python, you can use in, right? Where we have a list of names. You have Fred, Sam, and then you can do something like, is Sam in this collection? Right, and it returns true. You can do something like where name in Fred, comma Bob, and here this should be a tuple as well. Okay, so this is really equivalent, right? Very similar to what we see in Python, right? So returning a truthy value, and here's the same thing. Everywhere there's a truthy value, right? We are returning the row. Okay. One thing that helps, oftentimes when thinking about this, is order of operations. So it's loading data from the employees, then it's performing the where statement, and then it's deciding, and then you're selecting or deciding what columns to display. Okay, so this actually occurs last in SQL. Okay, so we do like ID, zip code, name, or you can change the order of this, right? And now there's the ID, the zip code, and the name. But there's no reason to do that. Yeah, so Connor was asking if the read SQL if this read SQL and Pandas can also work with other databases like Postgres. Yes, it can. It's a little trickier to do that, but we'll have to use SQL Alchemy. But yes, you can ultimately do something like that. Okay, so one other thing I should probably point out is these quotation marks are like a little confusing. Right, where like have to keep track of the double quotes versus the single quotes. One thing I like to do typically is separate this out, use the triple quotes, right, and then you can put query equals. This is still a way of declaring a string in Python, but this is for a multi-line string, and then you can plug this in here, select ID, name, zip code. You can put each kind of keyword is where you can press a return typically. So it's kind of like a different clause, right? So this is my select clause, from clause, where, okay? And now I'll just assign this to the variable query, and then I'll pass that query in as an argument, right? So everything here at this layer is still just Python, right? We're calling a method, we're passing through two arguments, the query and the connection, and then this part is the SQL statement, right? So it's going to take this string as the statement and run it against my database, okay? And now I don't have to worry, I can go back to using single quotes here, which I like a little better in SQL land, right? And here's my triple quotes, here's my ending string with the triple quotes, okay? All right, so this is kind of like the fundamentals of select statements. We have select, and this part we actually think of last. Select from employees, then the where statement limits the rows, and then finally inside here is what we want returned, and we know if we want all columns returned, we put a star right there. What's next, I suppose, is you can also do like order. So let's say we have from employees where the name is one of these two. And now let's order by the zip code, and we'll say descending, meaning highest to lowest, right? So we should actually see Bob show up first, right? Because it's ordering by this, okay? So you do what column you want to order by, and then in what direction. So now let's do by name descending, and that would be the highest to lowest again. So now Fred Bob. If I want to order by the name lowest to highest, that would be ascending, right? ASC. So lowest to highest is ascending, and that's right, ASC. And you can specify any column, obviously, to do that, right? So order by name ascending. Let's take out the where so you can start to see that a little better. So BFS, right? Cool. You can, and then you can also do a limit, is maybe the last thing, is let's select all from employees, order by some sort of, column, and now limit, and let's say limit 2. Notice I'm getting a little casual with the semicolon. Because I'm passing this through the pandas library, it just like, will do that for me. I don't have to be quite, it's okay if I omit that. So now I'll just do limit 2, so it still does Bob, Fred, but it stops after 2. Okay? Maybe one last thing, what else can I show you, is you can do order by, if there are ties, like let's say zip code, so let's say order by zip code, descending, let's say ascending, so lowest to highest, so the one ending in ones, right, will go first. And then I can do order by zip code ascending, then when there's a tie, let's order by the name descending. I think I just do this, name descending. You see that? So now Sally came first, because here's a tie, so we're ordering by this column first, and then when there's a tie, it should be Sally, Fred, right? The name descending. You guys got that? So I put a comma in between each one. And then, of course, we can tackle on the where clause. Select all from employees, where, order by. Where, let's say, ID in, let's say 1 or 2, right? Order by. So I could do 1 or 2. That's one way to do it. The other way I can do this is say ID is less than 3, you know, and that's another way. So I can also do the less than. One thing that's hard about SQL is just remembering how these go. You know, select first, from, where, order by. If you mess these up, it will break. Okay? So here I have the order by before the where. But that's incorrect. Okay? And the way you can think of it is basically like logically how SQL works is that first it's limiting down to the first 3, you know, to where this is less than 3, and then it's performing the order. If you tell it to do it out of step, right, it doesn't follow that syntax. Right? This will break. Okay? So the order in which you construct the clauses, add in each of the clauses, matters. And it will just break, and unfortunately the error message are not always so helpful. That's it for these readings. Questions about this? How does this feel to y'all? It will just take some practice. It will take some practice, all right? Don't worry, we have a lot of SQL material to move through. This will feel like a second language pretty soon. Cool. All right, so this is the idea. We have some data from Yelp, okay? And you can see, let's take a look at this. So we can see what we got. So these are restaurants in New York, Sweet New York. And we can see the name, right, and the address, right? And then we could see also like the city and the category and the rating. And then this is, someone scraped this from Yelp, right? So here's the Yelp URL. And then now now we want to basically ask questions of it. So previously, what we're really asking questions of and what we're returning is each individual row, okay? Like meaning, if I do select all from restaurants limit 10, what is each row? Like each row is a separate restaurant. Remember we talked about like the grain of the data, right? The grain of the data. And by that we mean like what does each row represent? So here each row represents a separate restaurant. Now, this changes when we move to aggregate methods, right? Because if I ask a question like, what is the max, let's say, rating from restaurants? Okay, what is that asking? That is asking, what is like the highest score the collection of restaurants have gotten? And then how many how many answers do you expect to get back? Probably just one, you know, like whatever the max is. So the point is the grain of the data will change. The rows will no longer be restaurants, but something else. So we can do select max rating, right? And we see that, okay, it's 5. We could do the same thing like min rating, right? And it's the same thing. There's only gonna be one answer for this. You can also do some things like the average rating, right? Average of the rating, and now this is the average rating, 3.89, okay? So the thing to remember with aggregates is basically the grain of the data, right, is going to change. This doesn't represent each restaurant anymore. It's of the collection of restaurants, all the restaurants, what is the average, okay? Other things you can do, like you can say, this average, like remembering the order of operations is still important because when does this average occur? Well, it's after you load up the data from, let me close my door, hold on. All right, so it's after you load up the data from the table, right? So select all from restaurants. Now look at this. If I do something like where the city is the Bronx, okay? So where the city equals Bronx, and I need to worry about my quotes, don't I? Okay? Now think about what's happening. we're selecting all from restaurants, we're scoping down to just city Bronx, and then remember this part happens last. So I would expect to see a different answer here. Right, slightly different. Not dramatic, but slightly different. So the where statement occurs before any of the aggregates occur. That's the point. Okay? I think you could also maybe do like limit. Let's say if we do like limit 2. Let's do order by the name of the restaurant, limit 2. So we'll order by the name, limit to 2, and then take the average. Order by capital name, probably. And let's just see if that looks accurate. How will we do that? Let's look at all the records. So read SQL, instead of average rating, let's like select all from restaurants. Where the city is the Bronx, order by name, limit 2. This gives us these 2. That doesn't make any sense. It didn't do it right. I'm sorry, gang. So I guess it does. Maybe I'm wrong. Maybe it's this order by and limit, I guess is happening after. Is I guess happening after the calculation. That's so weird. It might be a SQLite thing. I'm sorry about that. So let's forget about that. That was a bad example. So, okay, but the other point is the where statement. This is the main point. This where statement occurs first. This is regardless of the database, and then will occur the group by. So here I select all from restaurants where the city equals the Bronx, and then from there is the average rating, and there you can get the answer is 3.82. Okay, and that's different than all in New York, 3.89. One more thing before we move on. You see how this column, this gives us like kind of a new kind of like column almost to return. You can give this column a name. Really, you can do that with any of your columns, but it really makes sense here. And you can do that by saying as. Select average rating as average rating. So just give this an underscore. And now this has changed. Okay? You actually don't even need, I like this, having the word as, but if you don't want it, you can remove it, and it just knows that, okay, here is, you know, this means rename it. And this is called an alias, right? An alias. Okay. So these are aggregates. There's another step. This is actually what makes aggregates a little tricky, which is, what if we want to find the average rating of each city? You know, city in this data set is like the borough. Okay, so here's what we'll have to do. If we just do, you know, let's go back to select all. I'll keep this. We'll do a new line. So we'll do read SQL connection. Let's put a query here. And now, you know, just do select all from restaurants, and then do our query. Okay, so now we're selecting all of our restaurants. You can see there are these different cities. Okay, if we wanted to, I think you could do this: select distinct city from restaurants, and this shows you all the different cities there are. Okay. Now let's say we wanted to see for each of these cities, what is the average rating? Okay, so how do we do that? What you need to do is put this stuff into groups first. And this is again where you want to think about the grain of the data. Because if I'm selecting all the restaurants, then there's, you know, a lot of these guys. Select all from restaurants, there's a ton of them. But if I'm calculating the average per city, there's just going to be, you know, as many cities as there are. So it's distinct city. There's just going to be 84 rows, right? One for each city. So again, the grain of the data is changing. Okay, so now let's actually do it. Here's how we do it. We'll just select name for right now. Select name from restaurants. Then I'm going to do this. Not name, we'll do city name. City from restaurants, group by the city. And now we'll get one per each city. And now I'm going to say select city, comma, average rating as average rating. And again, notice there's 84 rows, but and so for each city now, we have a separate rating. So what you want to imagine, the way I what might be helpful with group by, what I kind of imagine lots of times is, we have this data, right? And this is like a restaurant for each one. So, there's Chipotle, there's McDonald's, there's Wendy's, right? There's BK, right? And then there's the Chipotle, again. And then we have the city name. So this is my restaurant, this is my name. And then we have the city name. And this is, the Bronx, Manhattan. Let's say Bronx again. Manhattan. And then there's our ratings. And that's, 4, 3, 5, 4, 4. Okay. And then we do this. We just say select all from restaurants, group by city. And then it's not select all, right? It's select name, comma, average rating. You want to think, so what happens is we load the data from restaurants, then the group by happens next. Okay? What happens in the group by is these guys go into piles. All right? So we take the guy from the Bronx, right? Because we're grouping by city. So all the people from the Bronx, they go in one pile. 2 of them. Right? Then all the ones from from Manhattan, they go in a separate pile. These 3. So this is the Bronx. And then we have Manhattan. And that has these guys. So these records, you can imagine, are in this pile. And that would be like the 3, the 4, and the 4. Right? These 3, 4, and 4. And then this guy, 4 and 5. And then our select statement comes and it says select name and average rating. And basically, we're just collecting 2 separate rows. We're going to return to you 2 separate rows, one for each of these different cities. And on this first row, we're going to kind of look through the data. And this data has just one name on it, right? Because we're grouping by that. Sorry, select city. This should be city. City. So this data just has one city value in this group, right? Because everything here is from the Bronx. So that looks good. So it returns to Bronx. And then for the average rating, there's just one value. It's the average in the Bronx. So that's 4 and 5. So this will give me 4.5. So the point is, imagine the data is organized into piles, and then SQL is calculating the values for each pile. Right? So there's one pile for each city. And now we go through this pile. This is only one city name, and that'll be Manhattan. So that guy's good. Right? We look through the data. And then the next one is the average rating, 3, 4, and 4. So it's 11 divided by 3, whatever that is, like 3.7 or something like that. And that seems a little low. 3.8, I don't know. 3.7. Okay, so this is kind of the process of group by. You're putting the data into piles, and then you're calculating based on each pile, right? So now let's go back to here. Select average rating as average rating from restaurants group by city. We're first putting the data into piles. So here's our different piles. One for each city. And you want to imagine each one of these rows here has a bunch of data inside of it. This is just a pile of data. And then you say what you want to see from that pile of data. We want to see the average rating as the average rating. Okay? You can do more than one calculation of that pile of that pile in a single query. So for example, if I want to see not only the average, but how many records are in each of these piles, I can do count, okay? And typically what you want to do is count star, count up. This is like across all the columns. There is a good reason for that. Just do count star for now. We can get into why later. And we can say this as amount. Okay, so this guy has a 4, but there's only 3 records in the pile. So maybe it's not a great sample size. So now what we can do next is start to say, what if we only want, records that have over, 10, or cities that have over 10 restaurants, or 10 restaurants in them, right? We want like a larger sample size. So we can get to that in a second. But before I do, are there questions about what we've covered so far? Does this feel all right? This typically is kind of confusing. Okay, here's the next thing. So now let's say we only want those restaurants that in the query. And we'll do pd.read query, connection, and select all from high schools. And now, okay, so this obviously just gave us all the high schools, but this question, which was kind of tricky, is like group by the math average. So let's select the math average from high schools. And then we could group, just for now, group by the math average. And then I think it also was the college career rate. Okay. So we are doing it, which I guess is nice. But the issue is it's like these groups are kind of arbitrary. Like it doesn't, group by 312. Like how many schools are actually in that group? Probably not too many. 315, 320. So what we want to do is group by like the 300s, group by the 400s, 500s. And we can do that. It wouldn't be so hard if this stuff was, if it was like 3.12 and 3.15, because then we can just round to the nearest digit and group by that rounding. Like we could round 3.12 down to 3, and this would also be down to 3, and then that way we could, again, group by that rounding, and we would be in good shape. So in order to do that, what we can do is we can divide by 100. All right, that might be the first step. So now, right, we got back down to the 3.12, and then let's round it to, we could do round to 0 digits. That works fine. But you can also just do this, and let's call this as like math range. And we can do the same thing over to the right here. Let's see why multiple lines is nice. Yeah. So now we'll round here. All right, we are in business. I think that's it, actually. All right, so we select round the math average. We divided it by 100. That gave us like the 3.1 stuff, 4.1, 4.5, and then we round to the nearest 100, and then group it by that bucket, by these buckets, and then perform our calculations from there, right? This is the average college career rate per that bucket. If you want to redisplay that bucket, right, you can just multiply by 100 again. And that's fine. So this is, if you have the 300, those schools that have like a 300 range, right, got 64%, went to college, 400 range. That doesn't make any sense. You know what? Let's times this by 100. Did I do something wrong? Oh no. Something's wrong. This looks off, doesn't it? I did this with some of you. I don't remember these numbers. Math range. Select 100. Let's divide this. Did it look better before this? It's just this one that looks off to me. Let's look at the count. Count star. Because maybe it's just a couple records. Look, this is so off. I don't know what's going on. Anyway, this is the idea. I think this is right. It's just the numbers scare me. 98%. Thank you. Let's see if someone has an answer. The 3 to 400 group is very small. I need to average the the college career column. Oh, thank you very much. This is bad. This is what's going on. Let me explain this. This, in many databases, this would break properly. This would give me an error. Because what I'm doing is remember we put their stuff into buckets? So I'm like putting everything with like the 300 range, right? All those records are going into one bucket. Okay? And then everything in the 400 range, that's going into another bucket. And normally what we do is we ask for like either what we're grouping by, like we're grouping by that, this 300 value or the 400 value, like we're displaying that, or we ask for like an aggregate query, right? Meaning like the average, right? Like the average score, career rate, okay? So that calculates it through this data. The problem I made was I didn't put average here. So what did it do? It just randomly took the top guy off the list and was like, oh, this was in the bucket, this was this school's average rate. And in this bucket, this was this school's average rate. This does not make sense. Like in Postgres, this would actually throw an error because we care about stuff about the group. We don't care about like a random school in this group. Okay? So it should have thrown an error. SQLite just doesn't do that for you. But let's change the query to average college career rate. And now this should be better. Okay, this is looking better. 45, 53, 75, 89, 95. That's good. We'll call this the average rate. Okay, so be careful about that. Like I said, once you get out of SQLite, it will properly throw an error and say, hey, you're not aggregating this thing like we expect you to when you're using a group by. Did that make sense? You guys get that? Yeah? Okay, great. Cool. So this is how you can do this problem. I put it in the Slack if you have questions. All right, let's move into the next thing, which is working with multiple tables. Give me 1 second. Cool. So here's what we're working with. We got albums like Spotify, right? Spotify albums. And you can see like I took these IDs, I think. This is the release date. I probably made these up. The Very Best of Prince is obviously a Prince album. Forever is also a Prince album. Stranger to Stranger is a Paul Simon album, which is a classroom favorite artist. And then we have our list of artists, right? Prince, Paul Simon, and Elvis. I don't know what this is doing here. Okay. So then let's say we properly are splitting this up into different tables. Let me explain why. Here's kind of the main idea. Let's say that we're like, why don't we put everything in one table? Like, why do we need to separate out, put this down here, have a separate table? So the issue that we would run into is, let's say we have like artist name, and then we have artist hometown, right? This is Prince, and this is Prince again, and then this is, Minneapolis, and this is Minneapolis again, right? And then this is Paul Simon, and I forget where he's from, NYC. So, let's say Prince changed his name, blah, blah, the artist formerly known, right? You have to do that everywhere, right? And that's where the problem comes in, because it's very easy to forget to make the change multiple places, okay? So or say you just learned that this was wrong information, or instead of using Minnesota with the abbreviation, you want to do the full. I apologize if I think that's the right spelling. You want to do the full spelled out word, right? So the problem is again that we now are representing the same information. This content is here twice, and that can lead to bugs very easily, right? Where we change one and we forget to change the other. So instead, you never really want to do this. This is, if you see information like this duplicated, like text duplicated, that is like a smell, basically, that something is wrong with your code. So instead, what you should do, another smell that you can kind of detect is, notice how there's a prefix here. Artist name, artist hometown. These have the same prefix, and that's indicating that, hey, this probably is not describing albums, but is describing another entity, right? This artist thing. So this is called data modeling, where you're deciding what belongs in what table and how many tables to have and all that stuff is very, very important skill. And right, there are these different hints. It's almost like a little bit of an art to it. But there's these different tricks that you can see. So the fact that I have this prefix, right? The fact that these two columns really go together, right? They describe this separate thing. The fact that this data is repeated. So if you imagine some mock data, if you can see that data being repeated, that's that's a sign that you should be changing this. Okay, so instead what do is we delete this, okay? And we have a separate table called artists. So let's move that up here. So now we still need to connect these guys. And the way that you do that is with what's called a foreign key. So let me just write that word out, foreign key. Okay? So it links a record to the primary key on the different table. So this is the primary key, right? It's the identifier of the album is 144, identifies this particular album. This is my primary key on the artist table. We identify it with the number 1. I guess it's Prince, 2 is Paul Simon, 3 is Elvis. So how am I going to say that Prince is the artist here? I'll have a column called artist ID, and then I'll put a 1 here. And then I'll put a 1 here, and I'll put a 2 here. Okay? So now this is saying the artist is going to be this guy right here. And this is saying the artist here is going to be Paul Simon. It's going to be Prince again. 1 lines up with 1, and then this 2 lines up with 2. Okay? So now we're able to kind of accomplish both goals. We're able to link up this album with the artist, and we're not duplicating our information, right? We're not saying Prince twice. And we're not saying, you can imagine, Paul Simon has other albums as well, etc. Okay? Does this make sense, how we do this? The next thing to do, I wish I had, I don't have, the next thing to do is to join this data together. So basically the issue is when we write a select statement, select all from albums, think about what occurs. We're loading this table into memory, just the albums table. We're not loading the artist table into memory. So what you need to do is you need to say albums, join the artists, okay? So I'm loading, and that's loading 2 different tables into memory. You may think that that's kind of good enough, but it's not. You have to specify how these columns line up, how the rows line up. So what you want to occur is that we line up this ID on artists with this column here. We want these guys to, when these two values equal each other, right? Those are the columns, those are the rows we want lined up. So we want to do that. And then we want, again, this 1 to equal that, right? And then we want this 2 to equal that. And this, remember, this is the ID column on the, I'm going to write it like this, on the artist table. This is the ID column on the artist table. So this is the result we want, right? Is we store this stuff separately, but now I want to write a query that returns this stuff combined and properly lined up. So in order to do that, you do select all from albums, join the artist table, and now we have to say how they line up on albums.artistid equals artist.id. So where this albums table's artist ID column, when the value there equals the value there, link them together. Okay? So this is the query. And then you can specify what columns you want to return. Okay, so it would be like you could say I want the albums dot name, comma, artists dot name. Notice what I'm doing is I'm preceding the column name with the table name. This is called the table prefix. All right, this is the table prefix. And basically, because I have two tables loaded into memory, artists and albums, it's not and they both have the same column name. I have to specify which column I'm talking about. This is always a good idea, really, to use the table prefix, but I have to use it in this case. So select albums dot name, artists dot name. From albums, join the artists, right? Join this table and link them up where the albums.artistid equals the artist.id here, right? And that will return something like this. I really like the, let me see if I can do Khan Academy SQL joins. I want to see if I can show you a good example. Okay. So this has student and student grades. Let's spin this off. Can I spin it off? Hold on. Your spin-offs. Okay. So this is, I really like Khan Academy for these things. So this has given me some sample data. Let me show you. So I have two tables here, persons and hobbies. We can select all from persons, okay? And that gives me these people with different ages. And then I'll put semicolon. And I'll do select all from hobbies. That gives me these hobbies. Notice each hobby has a person ID associated with it. So whose hobby is this? This is Bobby's. And then this one, coding, is also Bobby's. And then this one is this is Lucy's, and this is Lucy's, and this is Bananas. So now if I want to display, the actual person's name next to the hobby, how do I do that? So I'm going to select all from hobbies, right? So that gives me every row, all the columns, okay? And now what do I want to do? Let's join persons. And now look at this. There's too many rows. Let me show you what's going on. Okay, the person ID is 1. The ID is 1. Here it's actually lining up. But these guys do not line up, okay? We as human beings are smart enough to say that this person ID should line up with this ID right here. But SQL is not smart enough to know that, all right? Not without you telling it. So you have to say join persons on the, and then I kind of just remember what it is. I like looking at this stuff. It join persons on the where the person's ID equals hobbies.person ID. Persons.id equals hobbies.person ID. Now these properly line up. Person ID, person ID, person ID, person ID, right? And now these things are properly lined up. So just to review at this point, select all from hobbies. That loads hobbies table into memory. Join persons loads the persons table into memory. Now it will combine every single hobby with every single person at that point. So you have to specify how they link up. where the person's ID, this table's primary key, equals that table's foreign key. Person's ID equals hobbies dot person ID. Then these are all the columns you want. So if all you want is the name of the hobby and the name of the person, cool. How do we do that? We need the table prefix. So now it's persons dot name, comma, and let it hobbies, right, dot name. And maybe we can reverse this. Right? And you can do the same thing. Like if you want the ID, hobbies.id, right? This is each hobby and the corresponding person. So really, like what you do is you build the query over time. You don't have to write the query out all at once. Like you can see how I did it. It's like just select star, do the join, link them up properly, and then you can fill in the columns that you want. Right? You can be iterative with this. How does this feel to y'all? Yeah? You sure? Okay, so the last thing